All right, so this is part 2 of graphing general rational functions. And so as a quick reminder, when we are trying to find asymptotes, vertical asymptotes, horizontal asymptotes, it's a little more algebraic than using your transformations. For the vertical asymptote, you set the bottom of the fraction, the denominator, equal to 0 and solve for x. Okay, since this is a vertical line, it's going to give you an x equals equation. Okay, for the horizontal asymptote, remember that's the ha, the funny acronym, Bobo, bot, D neats, DC. Okay, bigger on bottom, y equals 0. Bigger on top, it does not exist. All the same, divide coefficients. Okay, and because these are horizontal lines, they all have y equals equations if they exist. They're horizontal lines. Okay, for the intercepts, the x-intercept, you plug in 0 for y, and solve for x. Okay, and so this basically is setting the top equal to 0, the top of the fraction. When you're solving for the vertical asymptote, you set the denominator, bottom equals 0. For x-intercept, you set the top equal to 0. And this time, instead of writing it as x equals, you're writing it as an ordered pair. Okay, and you fill in whatever that x value is. For the y-intercept, you plug in 0 for x. And essentially, you're just covering up all the x terms because they disappear, and you're left with the constants. And then this is also an ordered pair. You put the y value in the y spot, and you put 0 for x. Okay, so that's a quick summary. None of this goes away. We're still going to be doing that today. Only there's one more thing we have to watch out for. And so let me make sure I'm actually recording. Okay, I am. All right, so today we're talking about a different kind of domain restriction called poles, as you can see from the title. And so we have an exploration at the top just to kind of see what's going on. And so this isn't the method or anything, I just want you to see something. And so we have a quadratic over a quadratic here. And it says here, just plug these numbers in. Figure out f of -2, figure out f of 4, figure out f of 1. And so we're going to replace all the x's with -2 first. Okay, so I'm just going to use my calculator to save time. If I plug in -2 to the numerator, I have -2 squared plus -2 minus 2. So I end up with a 0 on top, and on bottom, -2 squared minus 5 times -2 plus 4 gives me 18. So since it says 0 over 18, 0 divided by 18 is just 0. If you want to verify that, it's 0. Okay, so f of -2 is 0. When that means we have the point -2, 0 on our graph, and we recognize that as an x-intercept. Okay, so -2, 0 is an x-intercept. If we plug in 4, as it's asking us to do right here, the top becomes 4 squared plus 4 minus 2. The top is 18. Okay, and then the bottom, 4 squared minus 5 times 4 plus 4 is 0. Okay, so 18 divided by 0 is not 0. That is error. Okay, if you type that in, error, divide by 0. You can't divide by 0. We know that's undefined. And so we know at x equals 4, that's our vertical asymptote. Okay, so x equals 4 is a vertical asymptote. It's where it's undefined. Okay, so 0 on top, that's our x-intercept. 0 on bottom, that's our vertical asymptote. And now let's plug in 1 and see what happens. Okay, so if we plug in 1, 1 squared is 1, plus 1 is 2, minus 2 is 0. So 0 on top, maybe this is an x-intercept. If we plug in 1 on bottom, we get 1 minus 5, which is negative 4, plus 4, which is 0 on bottom as well. Okay, so we end up with 0 over 0. And so it's kind of hard to tell, is this an x-intercept or is it a vertical asymptote? And it's actually neither. Anytime you have a 0 over 0 situation, that means there's a hole in the graph. Okay, they're also called removable discontinuities. Okay, and so at x equals 1, there is a hole, and we're going to see what to do with that. And so here it says determine the simplified form. That means we're going to factor the top, factor the bottom, and cross off any factors they have in common. And so I'm looking for two numbers that multiply to negative 2 but add to 1. That's x plus 2, x minus 1. On bottom, we're looking for two numbers that multiply to 4 but add to negative 5. That's negative 4 and negative 1. Okay, and so if you notice, there is a common factor that we can cross off. And so the simplified form of f of x would be x plus 2 over x minus 4. Okay, simplified form. So when it talks about simplified form, that's what it's referring to. And so now we're going to plug in all the same values. We're going to plug in negative 2, we're going to plug in 4, and we're going to plug in 1 and see what we get. So if I plug in negative 2 to this function, negative 2 plus 2 is 0 on top, and negative 2 minus 4 gives me negative 6 on bottom. Well, 0 over negative 6 is still 0, and so negative 2, 0 is still our x-intercept. If we plug in 4 to this function, we get 6 on top, and we get 0 on bottom, which is still error. So that, oh, I should have switched colors. So that is still our vertical asymptote at x equals 4. If I plug in 1, I get a 3 on top, and I get a negative 1 on bottom. No, yes, no, I get negative 3. Sorry, thinking ahead. Which gives me negative 1 when I simplify it. Okay, and so that means we have the point 1, negative 1 on this simplified form. And so what this actually gives us is the coordinates of the hole in the graph. Okay, there's going to be a little open circle on our graph at this point. So this was just for exploration. You're never actually going to be plugging in stuff like that. We're talking about what happens at x equals 1. There is a hole in the graph. Not an asymptote, but an open circle there. And so rules for holes. We can fill in the blanks now. if the numerator and denominator of a rational function have a common factor. So in this case, that common factor was x minus 1. Okay, a common factor x minus 1, for example. The function will have a hole at the x value that makes this factor equal 0. Okay, so in this case, it was x equals 1. Okay, so if there is a hole at x equals a, in this case, we had 1. So in general, if there is a hole at x equals a, in the unfactored, the unsimplified form, you will get 0 on top and 0 on bottom. Okay, and so that's what we saw here. We got 0 over 0. But once you simplify it and plug it back in, you're not going to get zeros anymore because you canceled that factor off. Plugging in 1 gave us the y value of the whole. Okay, so f of a in the simplified form will give you the y value of the whole. Okay, a hole in the graph is also referred as a, or referred to as a removable discontinuity. So vertical asymptotes is also a discontinuity. It interrupts your graph. They call this a removable discontinuity because once you remove that factor, the function behaves exactly the same, except there's an open circle instead of a point at that specific spot. So removable discontinuity. And so now that we know about holes in the graph, this kind of changes the steps for graphing functions because you have this simplification step. And so the order that you go in is going to be very important because otherwise you would think that this x minus 1 would lead to a vertical asymptote. Or if you were looking at it on the numerator, you would think it was an x-intercept. And so you have to go in a specific order to determine your key attributes. So when you're graphing rational functions, I always say find the y things first. Okay, and so step 1 is find horizontal asymptote. Okay, that's a y equals equation, and that's where we use the funny acronym. Okay, you want to do this before simplifying. You don't want to simplify, you don't want to factor anything. You want to go ahead and find the horizontal asymptote because it's easier to see the degrees before you factor degree 2 over degree 2. Okay, and so find the horizontal asymptote first. Also find the y-intercept first. Okay, that's where you kill all the x terms and you're left with the y values. And so from standard form, it's easier to see what's left behind. -2 over 4 would be our y-intercept. Okay, from factored form, it's harder to find. And so before doing anything, find those things. That's step 1 and 2. Okay, and then after you find those two, you're going to factor and simplify. Okay, and so if there's a common factor, you're going to have a step 3, which is find whole. Okay, that's where we found the 1, -1. Okay, find whole. You may not have a step 3. Okay, if there's no common factors, just like last class, we weren't dealing with removable discontinuities or holes, and so you didn't have a step 3. And then once you factor and simplify, if there's no holes, you can then find vertical asymptote, which is an x equals equation from finding where the bottom is equal to 0 and the x-intercepts. You're solving for x in both of these. Only one's an equation and one's an ordered pair. And this is from where the top equals 0. Okay, so find the y things first. Your y equals asymptote, your horizontal asymptote, which is y equals, your y-intercept. Find those first. Find the hole if there is one. And then your last step will be to find the x things, your vertical asymptote and your x-intercept. And so we are going to practice this on the back. We have 3 examples where we're going to go through and find all of this information and see what they look like on the graph.